Hello everybody and welcome to episode 10 of Remaking Cavestory in C++. This episode is called The Level Class Part 4. This is the final episode in this four-part, mini-series for the level class. I am Limeoats. My website's limeoats.com. My Twitter is @limeoats. This is my GitHub link, and this is my subreddit. So this might be another long episode like the last one, so we're just going to jump right into it. The problem that we are solving today, we need gravity to be applied to our player. Right now, he just kind of floats there with no gravity, so we have to add that in. Collision. Collision is not really an easy topic in game development. It's actually one of what I find to be the hardest topic in game development for the most part. But we work through that and we get nice collision in this episode. And then finally, we're going to be able to specify our spawn point in tiled. Instead of just passing in random coordinates like we are right now, we're going to actually graphically represent that in tiled where we want the player to spawn. So that's the goal of this episode. A few details that are important. Gravity constants. This is going to be our gravity. This is going to be our gravity cap. So the highest amount, the most gravity that can be applied, I guess, to the player before it caps off, so that he doesn't just keep falling faster and faster the longer he is falling for. And this is going to be our spawn point for this map. So now how are we going to implement all of this? With a lot of stuff. These are a lot of little things though. First we're going to add gravity to the player. Then we're going to create a side namespace inside globals to represent just the sides of things. It'll be useful for rectangles so that we know the left side, the right side, the top, the bottom. We're going to create our own rectangle class. Yes, there's SDLRect, which we've used a lot, but we want a little bit more functionality. So we're going to create our own rectangle class to use for collision and stuff. We're going to add collision recs to level. That is a vector of rectangles that represent all of the tile collisions in our level. Let me put vector in there so that we know. We're going to draw collisions in tiled, so that'll be interesting. We'll actually be able to just draw rectangles in tiled and we'll automatically collide with them once our code is written. Parse the collisions from the TMX file. Check tile collisions. That'll just be checking the player if the player is colliding with things. Bounding box, get collision side in sprite class. This should be two separate points. We're going to create a bounding box in the sprite class, and then we're going to create a function called get collision side, which will get the side that we're colliding on. Handle tile collisions in the player class. That'll be where the logic goes for what happens when we actually collide with a tile. Finally, we get to add it all to the game class. Then we're going to draw our spawn points in tiled. We're going to parse it and save it in our spawn point variable in our level class. And then we're going to change the spawn point in the game class to use our levels spawn point. And that is what we're going to do. So we're just going to go through these one by one like usual. So first things first, we need to add gravity to the player. So go to player.h, and what we need to do is we're going to first make a private variable called bool grounded. Grounded will be true if we're standing on the ground and false if we're not, if we're in the air somehow. Okay. Then we can go into player.cpp and go down to, well, first in the constructor for player, we need to be initializing some stuff. Dx to 0, dy to 0, facing to right, and grounded to false. We're probably not going to get the spawn point right on the grounded tile, or right on the tile, so that he's grounded from the start. So we're just going to start it out as false, and for a frame or two, he'll just fall. You won't even notice when you start the game, and then he'll be grounded, because we're going to set that to true. Okay. We're also going to actually go back to player.h and add a couple new functions. These are public functions. Down here underneath setup animations, we'll say const float get x const float get y const. All the consts are just because we're getting the variable, not changing it or anything. So that just makes sure of that. These are just getter functions to get our x and get our y. We're going to need those in a bit. So we could implement those right here. Right after animation done is a good spot. So const float player get x const, and this will just return x. Same thing for y. Get y const, return y. Good. And then all we need to do is go down to update, and we're going to apply our gravity. So let's put a comment here saying apply gravity. And before we do that, we need to go up to our player constants and set them up for gravity. So let's go back to our notes. Let me close out of a few things up here that we don't need. Alright, go back to our notes. We have gravity is 0.002f. So I'll say const float gravity equals 0.002f, and gravity cap was 0.8, I believe. Yes. Const float gravity cap equals 0.8f. So now finally, if we go down to our update function, underneath apply gravity, we will say if dy is less than or equal to player constant's gravity cap. Now dy, just like dx was our change in x over this frame, dy is our change in our y position over this frame. Stands for delta y. So if dy is less than or equal to gravity cap, that means we need to increase the gravity because we're not at that cap yet. Dy plus equals player constants gravity times the elapsed time. And that's it. That's how we apply gravity to the player. Then all we need to do is move by dy. So we're changing dy here, and then we need to actually apply that to our y variable so that the player moves. So y plus equals dy times elapsed time. And that should be it. Let's build. Let's make sure it all builds nice. It does. Run it. And the player's going to fall right off the screen. Because that's gravity. We don't have any collision in there yet, so he's just going to fall right through everything right off the screen. But that's good. That means our gravity works. We might tweak those. We're probably going to tweak those constants eventually to make them more Cavestory-like. But for now, they're pretty good. Next up, create a side namespace in globals. So go to globals.h. And what we're going to do here is we're going to go to the bottom down here underneath vector 2. We'll say namespace. Do I want to put it above? Yeah, all right. Actually, put it up here. We'll put all the namespaces together. Namespace sides. First, we're going to have an enumeration to represent what a side is. A side can be top, bottom, left, right, or none. It's always nice to have a default there, so none. That's fine. So that's what a side is, and then what we're going to do is we're going to make a function here, a little helper function, called const inline get up side, so of type side that we just created here, get opposite side, side, const. And this is going to return the opposite side of whatever side was passed in. So if it's on the top, it'll return, if we pass in top, the opposite side of the top is the bottom, so we'll return bottom. So a little shorthand to do that. If side equals top, then return bottom. Else, if side is bottom, whoops, return top. Else, if side equals left, return right. And if you don't understand the syntax, just listen to what I'm saying here, because I'm explaining it as I go through it. If this says if side equals top, then return bottom. Else, if side equals bottom, return top. Else, if side equals left, return right. Else, if side equals right, return left. Else, return none. And that's just how we get the opposite side of whatever side is passed in. Little helper function, we'll use it later for our collision. Great. And that's it. That represents our sides. We have an error. Non-member function cannot have a const qualifier. Oh. Alright. Get rid of that. Wasn't familiar with that error. Just get rid of the const. That's okay. Alright, so moving on. We created our side namespace and globals. Now we're going to create the rectangle class. Again, there is such thing as an SDL rect, but we're going to create our own for right now with a little bit more functionality that'll help us with collision. So make a rectangle.h in your headers folder. And a lot of this is just going to be obvious stuff, but I'll try to explain it as we go through it. Class is just going to be called rectangle. We're going to need to include globals because we're going to use the side namespace in a bit. So first we're just going to have an empty default constructor that we don't really care about. We're going to create another constructor that takes in an x, y, a width, and a height. Now we're going to implement all of this right in the header file. There's no point in really making a CPP file. It's not really that complex, and it's nice to have it all in one place for just this. So I guess we should make our well, I'll write this out, then we have to make these variables that we're initializing. We're going to have errors until we do that. That's okay. So x, y, width, and height. Just like that. They don't exist yet, I know. Go up to the top here underneath our class declaration and put public. We need to make a private now and actually create all of those variables. So int x, y, width, height. And now there's no more errors. Good. So now we're going to have a few very simple helper functions here to get certain parts of this rectangle. So for example, int get center x is going to get the center x position of this rectangle. Const int get center x const return x plus width divided by 2. So this function right here will take our rectangle and it will return the x position plus half the width, which is going to put us in the very middle of the rectangle, and it'll give us that position, that x position. Same thing for get center y, except we're using y plus height divided by 2. Then we want functions to get the left, right, top, and bottom of the rectangle. So const int get left const return x. The x position is the left side of the rectangle. Get right is x plus width, gives us the right side of the rectangle. Actually, let me draw this all out for you. It'll help you understand what I'm really getting at here. So let me go to new picture. Let me draw with my bad drawing skills for a second. Alright, so say we have this rectangle. This is our rectangle. This is x comma y. Right here. This spot right here is x comma y. Then from the top all the way down to the bottom is height. And then from the left all the way to the right is width. Probably know that already. So to get the left side, all I need is x, because we're here. To get the right side, I need x plus width. To get the bottom side, I need y plus height. I'm really bad at writing with my mouse. Y plus height is the bottom, y is the top, x is the left, x plus width is the right. Okay? So if I go back, the right was x plus width, then we need the top, get top, which is just y, return y. And then of course get bottom, as I said before, is just y plus height. So some helper functions there to get the left side, the right side, the top side, and the bottom side of the rectangle. Easy. And we can get the center of it and on the x and the center of it on the y. Then of course we just have a const int get width, return width, const int get height, return height. Alright, so then we have another function here that we need. It's called const int get side. It's going to take in a const sides side. And what this is going to do is it's just going to use one of these functions up here and return that side of the rectangle based on whatever side we pass in here. So it's the same syntax as before. If side equals left, then return get left. Else if side equals right, get right. Else if side equals top, get top. Else if, whoops, I wrote it out. else if side equals bottom, get bottom, else sides none, which is just a default thing that won't really be used. Okay? So that gets the side that we're dealing with. Then we're going to have a collision function, our first collision function. It's going to be called bool. We could say const bool collides with, taking in another rectangle. Const. So this function takes in another rectangle and checks if the two are colliding. And by the two, I mean the rectangle that we're in, because right now we're in a rectangle. This is a rectangle object that we're in right now. And then we take in another one of the same type and check if the two are colliding. So to determine if the two are colliding, if this rectangle's right side is greater than or equal to the left side of the other rectangle, and the left side of this rectangle is less than or equal to the other one's right side, and the top side of this rectangle is less than or equal to the other one's bottom side, and this one's bottom side is greater than or equal to the top side of the other one. Then it's colliding, return true. If all of these are true, return true. Otherwise, it'll return false and it's not colliding. Now, I'll attempt to draw that one too, because that could be confusing. Okay, so everyone got this. This is how we determine all those things. Make a new one. So say we have a rectangle here, and then quote runs into this one like this. So quote's rectangle collides with this one. So here's quote. Okay, there's quote. His rectangle collided. Now as you can see, the right side is indeed greater than or equal to the other one's left side because it's colliding. So the first one passes. The left side is indeed less than or equal to the right side. See, my left side is less than this one's right side. My top side is less than the other one's bottom. Wait. My top is less than or equal to the other one's bottom. This is my top. Oh, of course. Y is at 0 up here, and Y is at a higher number down here. It goes up. So of course my top, my Y, is less than this one's bottom. So and then that works. And then my bottom is greater than this one's top. Bottom, top. So it's higher. So it passes. It is colliding. If it wasn't colliding, though, say I erase all of this and make a case where it's not colliding. Ew. Hold on, let me just undo. Say I make... Alright, I guess I'm using the pencil this time. Say I have this box and I have this box. This is quote. His hat. They're not colliding, so that means at least one of these is going to fail. My right is greater than its left, which is true. So that first one passes. my left is less than, the other one's right. And that's not true. My left side here is greater than this one's right, not less than. So the whole thing fails, and I'm not colliding. So the algorithm works. So that's how we check if two rectangles are colliding with this function. One more little function that we're going to use later on, const bool is valid rectangle bool, const, sorry. Okay, this just checks if a rectangle is valid. So if the x is greater than or equal to 0, and the y is greater than or equal to 0, and the width is greater than or equal to 0, and the height is greater than or equal to 0. 0, 0 is the far left side of my screen, so an x and y cannot be less than 0. A width and a height definitely can't be less than 0 because a negative width or a negative height means nothing. So this is a valid rectangle if all those pass. Okay? And that's it. That's our rectangle class. So good. So now we can go on to the next thing. Add collision rex vector to level. Alright. So go to level.h. And what we're going to do is at the top here, we're going to include rectangle.h that we just created. And down here in our vectors, we're going to make a new one. A vector of type rectangle called collision rex. And all of our tile collision rectangles will go into this vector. And then we'll check them off. We're also going to have a function here. I might mention that in the next point. No, I'll write it now. We're going to have a function here called vector. It's going to be check tile collision. It's going to take in a const rectangle other, and that'll check tile collisions against another rectangle. So let's implement that now. Go to level.cpp. And down at the bottom, above update, below update, and draw, we'll put our new function, it returns a vector of rectangles. So what this does is it goes through all of the tiles and checks if they're colliding with this other rectangle, whatever it might be. It could be the player, it could be an enemy, it could be anything. And it will add it to a list and then return that list of rectangles. So it'll return every collision rectangle we're colliding with. There might be more than one if we're standing between two on a seam between two different collision rectangles. So we need to return a whole list of them. So a temporary vector of rectangle called others. Then we're going to loop through our collision rex. Again, these come from tiled. We're going to add those into tiled in a bit. We're going to check if any of our collision rex collides with, that's the function we just wrote in our rectangle class, other. If it does, we're going to add it to this others list. Okay? And then after all that, we're going to return whatever rectangle or whatever collision rex we're colliding with. Others. That's it. So now we can move on to drawing the collisions in tiled. Yay. So go ahead and open up your map in tiled. What we're going to do here is we're going to click on objects over here, this little paper here to make something new. This object layer 1 will appear, rename it to collisions. And now click on this rectangle thing. All right. Now you can click and drag and draw collisions. Well, draw rectangles, and we're going to turn them into collisions. So just keep on, make sure you have collisions selected here, and just keep on drawing collisions wherever you see fit. At this point, you should probably just download my my version of this, because these collisions might not be precise on yours, or it might be just a little bit different and make something weird later on. So I recommend you just download mine and keep it up to date. But you could do your own, it's fine. You could draw a collision here so that we don't run through the wall. Another one here, like this. We're going to add slopes in, so I'm not really drawing them where slopes are going to go. Slopes will be in the next episode. Some more here. So wherever the left, right, top, and bottom of these rectangles I'm drawing are, we're going to collide with those. Now, the less you put in, the better, because less things going around that loop every time. But, you know, you could... We're not adding that many. It's not like we're having one per tile. That would be way too much. So it's not too bad. That's good enough for now. I'll probably add more in. Well, I'll definitely add more in once, but I want to get slopes all taken care of first before I really start making this perfect, because we have slopes here. All of this is slopes. I don't want to draw solid lines over it. I'll put one here for right now, just so we don't fall through the ground. There we go. And of course, one more. Perfect. Go ahead and save that. They're all over here. They don't have a name. You don't really need to give them a name. Doesn't matter. Save. And now let's look at what that looks like in Sublime. So not this one. This one. It looks like this. It's called an object group named collisions, because that's what we named it. And there's an X, Y, a width, and a height of each rectangle we just drew. So we need to parse that out, store it as a rectangle into our collision rex vector. So let's do that. I believe that's the next thing on our list anyway. Parse the collisions, yep. So go into level.cpp, and in our big load map function, we're going to add some stuff. So down here underneath layer, make some space. I'll make a comment here, parse out the collisions. XML element P object group equals map node first child element object group. So from the map node, the first child named object group will indeed be this one. Its name is collisions, but we're going to make sure of that because we're going to have more object groups in our maps than just collision rectangles. So the usual if P object group does not equal null, while P object group P object group equals P object group next sibling element object group. So of course that's just the usual thing to keep everything going. If there's more than one object group, we got to go to the next one. So now we're going to figure out which object group this actually is. So const char star name equals p object group attribute name. That's our name attribute right here, which will return collisions. Of course, that's a const char star. We need it in a string. So std string stream ss. Get it into that string stream, and now we're going to check it. We're going to see what our object group is. If ss.str equals collisions, then we're going to do our collision code right here. Parse it out, our parsing collisions code. And I'm going to put a comment right here saying other object groups go here with an else if ss.str equals whatever the name is. So when we have spawn points later on in this episode, we're going to put an else if here, else if ss.str equals spawn points. And then we'll parse those down there. But for right now, we're just going to worry about collisions. So right now we know that we're in our collisions object group. So now the next thing in here, we have there's a lot of object elements. So we have to get those. So XML element p object equals p object group first child element object. So I'll get the first object. If p object does not equal null, while p object equals p object next sibling element object. Same thing as always. Good. So now we're just going to very simply parse our x, y, width, and height from each object and store the rectangle in our collision rex vector. So float x, y, width, height. X equals p object float attribute x. Y equals p object float attribute y. Width equals p object float attribute width. And of course height equals p object float attribute height. And now one more line just to add this to our collision rex. Collision rex dot pushback new rectangle, and our constructor for our rectangle class takes in an x, y, width, and height, which we have, though it takes them in as integers. Right now they're coming out of tiled as floats, so because they're these decimals here. So what we're going to do is we're actually going to take the ceiling. We're going to use the math ceiling function to on this float, which will round up basically. Better than rounding down. If we were to round down, then we might end up making the collision just a little bit too small. We might fall through the map or something weird might happen. It's always better to go bigger than to go smaller with collision. So we're going to take the ceiling function of whatever it is we have there for each one of these. So I'll do this on a new line like this. I'll say ceil, std ceil, x times sprite scale. We still have to multiply by sprite scale. Ceil our y times sprite scale. Ceil on width times sprite scale. And the same thing on height. Okay. Close that up. Great. What's the error here? I don't think there is one. Alright. Good. That's it. Pile that. Make sure it all builds. It does. So that right there parses our collisions out of the TMX file. Perfect. So now we need to use it. We need to use our collision rex vector. So I parsed the collisions. Now I need to check tile collisions. So first things first, go into player.h. Actually, don't go into player.h. Go into sprite.h first. We're going to add a bounding box to all of our sprites first. So sprite.h, we're going to include rectangle at the top. And we're going to include globals because now we're going to have a new variable down here, a new protected variable of type rectangle called bounding box. And what a bounding box is, if I go back to my picture, this rectangle around the player, that's the player's bounding box. It's just a rectangle that goes around the entire player sprite. Obviously, it's going to be tighter than this. It'll actually be like this, based on the player's x, y, width, and height. So that's the bounding box. It's a nice tight little rectangle around it. Every sprite's going to get that. Tiles aren't sprites, so they're not going to get it, which is good. We don't want them to. Two public functions we need to add here. A const rectangle get bounding box. Whoops. To get our bounding box, and a const side get collision side, which will get the collision side of the bounding box and the rectangle that gets passed in. And that's it. So now go into sprite.cpp so we can implement these. So go underneath, well, first we need to, in our constructor up here, say bounding box. We need to initialize bounding box to something. Bounding box equals new rectangle, x, y, width times sprite scale, and height times sprite scale. Okay, and then in our update function, we actually need to now, every frame, update our bounding box so that it follows the player. So bounding box equals rectangle, x, y, source rec dot w, source rec.h. Good. Now we're just going to implement those two functions that we just created. So const rectangle, whoops, sprite get bounding box const return bounding box. Regular old getter for our bounding box. Now, though, we have a more complicated function. Get collision side. It's going to determine which side the collision happened on. So const sides side sprite get collision side, passing in another rectangle. That prototype up here, that's quite a handful. And now we need to determine what side the collision happened on, so that we can later on act accordingly based on what side is actually being collided on. So what we're going to do that is we're going to figure out how much our rectangle is inside the other rectangle on each side. So the amount that it's in on the right, the amount that it's in on the left, the amount that it's in on the top, and the amount that it's in on the bottom. And then we'll be able to figure out which side it's actually colliding on based on which one of these is the lowest. The lowest amount that it's in is the side we're colliding on. And when I say in, I just mean overlapping. Not necessarily inside, like the top, for example, might not be inside the middle of the other rectangle, but it's still a big amount. The difference there is still a big amount, so it's not going to be colliding on that side. It'll be colliding on whichever one is the lowest. It'll make more sense once I write it out. So amount right equals our bounding box. Our bounding box is right side minus the other one's left side. That's how much we're in on the right. And I'll draw that briefly. Let me undo all this. So we have a collision here where my sprite ran into this one. So here we are. This is our sprite, our bounding box. So what we're saying here is the amount we're colliding with on the right is our right side minus the other one's left side. So this minus this is the amount we're colliding on the right. Makes sense? Amount left equals the other one's right minus our left. So the amount we're colliding with on the left is this one's right minus our left. It's a very big number, meaning we're not colliding on the left. But we'll determine that later. Amount top equals get bottom minus get bounding box get top. So the amount top is the other one's bottom minus our top. So the other one's bottom minus our top is going to be a big number again. The absolute value of all of them, by the way. So it's going to be a big number, meaning it's not the side we're colliding on. And amount bottom equals our bottom minus the other one's top. Which again, our bottom minus this top, the absolute value, it's a big number, so it's not that side. The smallest one's going to be this one because we're just barely colliding with it. We're just barely inside it. So it's going to be the smallest one, and so that's the side we're colliding on. That's the algorithm. So now we just have some code here to figure out which one of these numbers is the lowest. In C++, there's no quick way to do it, unfortunately. So we have to create an array of the absolute values of all of these. And then we're just going to loop through the array to figure out which one's the lowest by overriding that lowest variable. So if the next one in the array is lower than the one that's currently the lowest, replace the lowest with that one. Through all of them, we end up with lowest being the lowest one of these. And then just one more of these returns. If lowest equals the absolute value of amount right, then return the right side. That means we're colliding on the right side. Same thing for the rest of them. If none, return sides, none. All right, and that is how we get the side that the sprite is colliding with the other rectangle on. So now we're almost there. Hang in there. Next, all we have to do is one more function in the player class. Let's go into player.h, and we are going to add a function called handle tile collisions. Put it right here. Passing in the vector of rectangles that we already determined that our player's colliding with stuff at this point. One or more rectangles is inside this vector, so we're going to handle the collisions with each of those now. So go to player.cpp and let's implement this. So we'll do it underneath the stop moving function. I'll put a comment, handle tile collisions, handles collisions with all tiles the player is colliding with. Okay? So void handle tile collisions vector rectangle others. So now the first thing we need to do here is figure out what side the collision happened on and move the player accordingly. Okay? So we're going to loop through that entire list of other rectangles that we're colliding with. So for in I equals 0, I is less than others dot size, I plus plus. So first things first, get the side that we're colliding on. So sides collision side equals sprite get collision side others at I. So now collision side, using the function we just wrote, figures out which side is being collided on. If collision side does not equal sides none, just making sure it's not sides none, there's no errors or anything, we're going to switch on collision side and then check all the sides and handle each one. So say the player is colliding with a tile on the top. What we want to do is we want to set the player's y equal to the other ones, the tile's bottom plus 1. So if the player's colliding with the tile on the top, let me open up tiles here. Let me zoom in. Say the player jumps and his head hits right here. It's going to go in its bounding box can go in 1 pixel here. Okay? So it'll be colliding. So what we want to do is we want to then set the player's position equal, the y position equal to this one's bottom. So it'll put it right outside of the rectangle collided on, and it will hit, but it won't go through. It'll just always go right back to the bottom here. So what that does for us is we'll no longer go through things. It'll stop us. We're also going to set dy equal to 0 because we hit something. So reset all gravity and break. If we collide on the bottom, meaning we're on the ground, we're going to set y equal to others at I get top. So the top minus the player's bounding box height minus 1. So if we're touching something on the bottom, set our y equal to, I'll go back to tiled. If we hit this one on the bottom here, the bottom of our box hits it. It'll be in 1. Set our y equal to this one's top. So then the top of the player's head would go here. But no, minus the player's height. So the top of the head would go here. And it would look like I'm standing on top of it. Okay? Set dy equal to 0 because we hit the ground, and of course set grounded equal to true because we're on the ground. And break. Then we have our left. Say we hit the tile on the player's left. We're going to say x equals the other tile's right plus 1. So we just put the player on the right side, right on where the right side of the other tile is. Break. And finally, if we collide on the right, x equals the other one's left minus the player's width. To put him in the right spot. And break. And that's it. So I know it was a lot of code, but we now have collision written. So make sure everything's still compiling. And it is for me. Now all we need to do is we need to go into our game class and call all of this. So why don't you go ahead and open up game.cpp. I don't know why I just opened up game.h. Open up game.cpp. Scroll all the way to the bottom to our update function. That's where we're going to check all of our collision. So we'll update the player, update the level, fine. But then we're going to check collisions. We're going to create our vector of other rectangles. And now what we're going to do is we're going to check all the tile collisions with the player. So if others equals this level dot check tile collisions, passing in the player's bounding box size, passing in the player's bounding box because it wants a rectangle, dot size is greater than 0. Whoops, there should be 2. So what this is saying is it's going to set this vector equal to the result of this check tile collisions function that we wrote before, which returns a vector of rectangles. And check tile collisions wants another rectangle to check against. It's going to check all of the collision rects in the level against whatever we give it. We're giving it the player's bounding box. So if that returns at least 1, if it's greater than 0, whatever that returns, at least one rectangle we're colliding with, handle tile collisions, giving it all the ones we're colliding with. We'll say player collided with at least one tile, handle it. Build, we're done. Let's run this and see what happens. Okay, so as you can see, I fell and I collided with something. I collided with, if I open up tiles, I collided with this rectangle here, right here. Let me reposition myself so that I spawn in a better spot. What did I say was the good spawn point? 280, 252. 280, 252, run. Okay, so we spawn here. And look, we're colliding, we're running. We can run into the walls, we fall, we collide with this stuff. Fantastic. We're colliding with all of our rectangles. So it works. Nothing's jittery, nothing's weird. If we stand still, he's not bouncing or anything, he's just colliding. Okay. So that's that. We just implemented collision detection successfully. So now we're quickly going to go through implementing a spawn point. So the first thing we're going to do, go into tiled. We're going to add a whole new object layer. So we can call this spawn points. And while that's selected, select this circle thing. And then down here in colors, I'm just going to make mine bright green so that it's very obvious where the spawn point is. Just draw a little circle wherever you want it. Right around there is a good spot. We could tweak it later, but that's good enough for now. I'm trying to hurry up because this is a long episode. If you go back into our TMX file, you'll see another object group shows up called spawn points. You don't have to worry about the color, it doesn't matter. Spawn points. It has an X, Y, width, and height, and floats again. That is our spawn point. So we're going to use that instead of just writing it right into the code. So go into level.cpp and go back down to that comment we wrote about other object groups, because now we're adding another object group. Okay? You can say, just as the comment says, else if ss.str equals spawn points, XML element p object equals p object group first child element of type object. Same stuff as before. If p object is not equal null, because we could have more than one spawn point. Go back into tiled. We're going to name this spawn point. So go into objects, expand spawn points, and see how it's blank here? Double click. Call it player. This is the player spawn point. That's important because we're going to have enemy spawn points in there too later. So make sure you call it the player spawn point. I forgot that. So if p object is not equal null, while p object equals p object next sibling element object. Yes. So now we need to get those x, y, width, and height. Well, we don't care about width and height. We care about x and y. So float x equals p object float attribute x. Float y equals p object float attribute y. We want the name of the spawn point as well. We want player. So const char star name equals p object attribute name. Now be very careful with all of this. One little mistake is very hard to debug, but I'm going through it kind of fast because it's all the same exact stuff we've been doing to parse this file. Then we want a string stream, get name in there, and now we're going to check what the name is. If it's player, that means that this is the player spawn point, not some enemy spawn point or anything. We're going to set our spawn point in our level class equal to vector2, and we're just going to take ceiling of x and y, well, ceiling of x times sprite scale, ceiling of y times sprite scale. Okay. And that's it. That gets our spawn points. So now all we need to do all that's left is to just use it. So go into level.h. We need a function to get the spawn point from the player, or from the level class. We're going to need it in the game class. So right here, just make a const vector2 get player spawn point. Const. Okay, and then we need to implement that, which is pretty simple. So go into level.cpp and you can just go all the way down to the bottom. Const vector2 level get player spawn point. const return spawn point. Yay. Then one thing we need to do actually before we use this is go into player.h. And we need to change, instead of, in the constructor, instead of taking in a float x and a float y, we're instead going to take in a vector2 spawn point, like that. Alright, and then we also need to change that in player.cpp, so go there. Just make it, instead of float x and float y, just take in a vector2 spawn point. Oh, why do I keep doing that? Spawn point. And now, without further ado, go into game.cpp. And up here, where we initialize our player, instead of passing in these two, this 280 and 252, well, first level needs to go first, so switch the order so that level and player comes after level. Now all we need to do is say level.get player spawn point, and that's what we pass in. And now the player should spawn wherever we put that little thing, that little circle. I have an error here. It says use of undeclared identifier x. Oh, I know why. Yeah. We're still using x and y here. So instead, just say spawn point.x and spawn point.y. Alright, that compiles. Run that. And now he appears there very nicely. To prove it worked, let's select our spawn point and move it. Put it like up here, for example. Run the code, and he spawns up top. And then he falls down because our collision works, and all is good. So our spawn point works. You can just put him down there anywhere you think is pretty good. He'll kind of push himself out within the first frame. You won't even see it if you spawn him inside the block, so it's okay. And it all works very nicely. So this was a very long episode, but we managed to get through all of it. We have collision and we have spawn points and gravity, and it all works. So let's very, very, very briefly talk about next time. I'm actually gonna split these up into the 2 points. We finally finished the level class. Part 4 is the last part. Or did we? We're not. Well, let me just show you what the next thing that we're doing is. The very next thing we're working on is slopes. A very complicated subject. Slopes is something that I have always thought about. It's what makes collision detection extra challenging, but I'm up for the challenge and I will be working on this. And slopes will be in the very next episode, which will hopefully be very soon. So keep an eye out for that. Again, I'm LimeOats. My website's limeoats.com. My Twitter is @limeoats. Please follow me there. If you have any questions, you can tweet at me. It will get my attention faster than anything else. My GitHub, where all this code will be, including the map file with all the collisions and the spawn points and stuff. So check that out. And my subreddit, where you can ask questions, start discussions, do all sorts of stuff. All the videos will be posted there, etc. So please follow me, subscribe on YouTube, do all that kind of stuff so you see all the next videos. And I will see you all next time. Thank you very much for watching.